Okay, well this result that we come up with where the remainder as a function value is actually stated as a remainder theorem, and another observation when the remainder is 0, that's stated as a factor theorem. So let's look at the two theorems. The remainder theorem says this: if a polynomial function f of x is divided by x minus c, which is what we did on the previous page, then the remainder is equal to a function value f of c. So if you're dividing by x minus c, the remainder is actually the function value f of c. The factor theorem says this: if you're dealing with a polynomial function, you do some synthetic division, and the remainder is 0. Just kind of stating in other words, you're dividing by x minus c and the remainder is 0, then x minus c is a factor. And it's important for us to find factors because from that we can find zeros. So it basically says that in these two, A and B, part A and B. If x minus c is a factor, then f of c is equal to 0. That means when you plug in the number you get 0, or your remainder is 0. This is saying if your remainder is 0, then x minus c is a factor. So factors and remainders of 0 go hand in hand. Remainder theorem, the remainder is a function value. Factor theorem, if the remainder is 0, then you have a factor. So let's first use the remainder theorem. Now we don't want to use old school method of finding a function value. We want to use this new synthetic division method. And if it asks you to use the remainder theorem, guaranteed the remainder theorem means use synthetic division. So let's set this up for synthetic division. We'll have the box, we'll put the number in the box, and let's record our coefficients. Fifth power, then a fourth, which is missed, then a third, a square that is skipped, then a first power, then a 1 will yield me the coefficients of 6, 0, 10, 0, 1, and 1. 0 for the skipped x to the fourth, 0 for the skipped x squared, and then the part that goes in the box, which could be a little confusing. So we have our coefficients lined up. The number that's going to go in the box, be careful when we're working with function values and they tell you the value exactly, you don't change your sign. In the box we drop the -2. No sign change here. The only time we'll change the sign when we go to the box is when it's given to us in the format of we're dividing like by x plus 2 or we're dividing by x minus 7. That's when we change the sign, when it's in this format, not when they tell us the value that they want us to plug in. Be careful with that. Well, let's do our procedure. Let's drop the 6, multiply -2 times 6, -12, add it to 0, -12. -2 times 12, 24, add that up, 34. Times a -2 will be a -68. Times 2, okay, let's just pull that out. 136. And it's going to be a positive 136 plus 1, 137. And then 137 gives us 274. So it'll be a -274, and so we get here at the end a -273. Make sure my signs are okay. -137, -2, that's negative, and then subtract 1. So now what we're going to have in an answer blank is what is the value of p of -2? P of -2 is equal to what? We don't write the whole quotient. Since we're working with the remainder theorem, we only write the answer of the remainder. So P of -2 is -273, but you have to show me using the remainder theorem, and this stuff is the remainder theorem. You can plug in a -2 to check your work, but don't plug in a -2 when you're using the remainder theorem. Let's do the same thing once you work on this one. Get it set up with the box. And the number that's going to go in the box doesn't change sign, so in the box we'll put a 1. And it's the same polynomial, 6, 0, 10, 0, 1, 1. And drop down the 6. And we're looking for the answer to P of 1, the function evaluated at the number 1. Work it out and see, what you get. Okay, so see if you get 18 on that. That's the remainder theorem. The remainder that you get in synthetic division is a function value. Now let's use the factor theorem. And if we look back, the factor theorem said when we're doing synthetic division, if the remainder is equal to 0, then what we're dividing by, that x minus c, is a factor. We need to keep in mind also that if something is a factor, it also gives us a 0. So I'm going to state another thing right here before we work this problem. If the remainder is equal to 0, then the number you're dividing by, we'll just say c, is a 0. So we're looking for remainders of 0 that will tell us we found a 0 to the polynomial function. Well, let's see how this problem is stated. We're given an equation, and they ask us to solve it, and they tell us one of the solutions is negative 2. It says negative 2 is a 0 to this polynomial. Well, if it's a 0 to this polynomial, then it's actually going to be a solution to this equation. Zeros of polynomials are actually solutions to the equivalent equation. Well, if I know that negative 2 is a 0, I'm going to assume it's a solution, and we're going to use the factor theorem to find the rest of them. So let me show you how to get started with that. We're going to have our box. We're going to do some synthetic division. The question is, what's going to go in the box? Well, what have we been given? We're given negative 2 is a 0. So what's going to go in the box is negative 2. No sign change here. It's not saying x plus 2 or x minus 2. They're giving us the value exactly as negative 2. So that's what's going to go in the box. Now, as far as our coefficients go, we'll have the 2, we'll have a negative 3, we'll have a negative 11, and we'll have a 6. Bringing your coefficients down, 2, negative 3, negative 11, 6. There aren't any missing powers, any skipped terms here. So we don't need any zeros. And let's bring down the 2 and get started. Since I'm given that negative 2 is a 0, which means it's a solution, I should be getting a remainder of 0. Let's check that out. Negative 2 times 2, negative 4, add those up, negative 7. Negative 2, 7, 14, add those up, we get a 3. That gives me a negative 6, and yeah, I expected to get a remainder of 0 because they told me negative 2 was a 0. So there's one of my solutions. The question is, how many solutions does this thing have? I mean, that's one of them. Let's try to find the other ones. Well, we're actually looking for 3 solutions. What we'll see as we go through this section and the next one is the degree will tell you how many solutions or how many zeros you're going to have. So just as a note here, let's just put this here on the side. The degree determines, oops, that's not very good. The degree determines the number of zeros/solutions. Since the degree here is 3, I'm looking for 3 solutions. Well, now we're looking for basically the two needles that are in the haystack, because I know one of the answers, but I have to find the other two, since there's going to be a total of 3 solutions. So this problem is going to have 3 solutions. Here's what's going to happen. Let's look at this quotient that's left. If I go ahead and write in my x's, it'll be a 2x squared minus 7x plus 3. This guy is quadratic. And I'm going to have these, in the book's going to have these set up where they're going to get you primed with one of the answers. That'll be enough to do synthetic division and get it down to a quadratic. Once it's down to a quadratic, you can either factor if it factors or use the quadratic formula if it doesn't factor. On the quadratics in 3.1, we use the quadratic formula to find x-intercepts. Remember the relationship here. Zeros are the same thing as solutions are the same thing as x-intercepts. So we're all looking for the same thing, it just might go by a different name. So let's find the last 2. Notice the degree is 2. That tells me there's 2 more solutions hidden in here. Let's set that quadratic to 0. And I believe it's going to factor, let me check it out, 2x and x, 3 and 1, negative, negative, let's see. That's a negative 6 and a negative 1, which is negative 7. Yep. And negative 1 times negative 3 is positive 3. Great. If it factors, remember your next step is set each factor to 0. And solve it. So we get x equal 1/2 and x equal 3. So what are the 3 solutions to this equation? Well, the one they gave us, which was negative 2, they gave us that one at the beginning. Then the other 2 that I found, x equal 1/2 and x equal 3. 3 solutions, negative 2, 1/2, and 3. Let me show you a really neat thing you can do on your calculator to check your work. Let me clear out my calculations there. And let's take this polynomial function, which is, where is it? There it is. Let's type in this polynomial function we have right there. 2x cubed. Let's see if I can bring this in a little bit so I can pull it up and do it. Come on, let me get in there. Won't let me. Okay, I can't get to the 2. You put it in your calculator while I try to figure this out. Two x cubed minus 3x squared minus 3x squared minus 11x plus 6 minus 11x plus 6. So what I've done is I've gone to the calculator and under y equals I've typed in this function. And remember, the zeros of this function are the same thing as the solutions to this equation. Functions have zeros, solutions have equations have solutions. Same thing. Now I want you to go to Zoom 6, our standard viewing window. Oh darn, things run a little slow. Okay, we're at Zoom 6. Press enter. And it's going to graph the picture. Well, you may not see too much there. But here is an interesting thing you can do. Go to the table feature. Now remember, x-intercepts or zeros or solutions will be those x values that give you a 0 in the y slot. Oh my goodness, I must not have typed that in right because 0, 0 is not a solution. Let me go back and see if I typed it in right. 2x cubed minus 3x squared minus 11x. Aha! Forgot plus 6. Very good. Well, that's not going to help me. Let me type in plus 6. So when you do this, just make sure that you type it in the right way. Now there is the right equation, the right graph. Now what I wanted to show you was if we go to the table feature, we should see all of those solutions that we have listed on the right hand side, the 1/2, the 3, and the other one, which was a -2, here on our display. Notice at -2 I get a 0. That means that is a 0 or a solution or an x-intercept. Let's go down and investigate some other values. Oh, there's 1, 3. When you get a 0 in the y position, that means that number in the x position is a 0. So there's 2 of them right there. So I'm kind of validating the work that I did over here. I found 1 at -2 and I found 1 at 3. Now because we were in this particular window, it's not showing me the 1/2 because it's a decimal, but here is something you can do. Type in 1/2. Just right at this point, type in 1 divided by, not going to let me do it, huh? Let's go to the graph and trace. Now hit 1 divided by 2, and what it does is it plugs in an x value of 1/2 and gives you the answer to be 0. There is the third number, and it just validates the work that we did over here by doing synthetic division and finding the solutions of that equation. Those 3 solutions are also validated on our graph as these 3 spots: the 1/2, the -2, and the 3. So you can use your calculator to kind of determine if you did the work correctly. Let's look at another that involves a solution. We've got an equation. It's a 4th degree. So if the degree tells me how many answers I'm going to have, because this is a 4th degree, that means I'm going to have 4 solutions, which is the same thing as 4 zeros, which is the same thing as 4 x-intercepts. These are all the same thing. Solutions come from an equation, zeros and intercepts come from a function. We want to solve it, we want to find all 4 solutions, and they've primed us, they've given us 2 of the solutions. If I know 2 solutions, how many are left? Well, if there's a total of 4, they've given 2 solutions, we need to find the other 2. You will always be given enough information to find the other 2, and the other 2 will end up coming from a quadratic like we saw earlier. See? The degree was 3. They gave me 1 answer. It dropped down to a quadratic. I found the last 2. The degree is 4. I've been given 2 solutions. I should be able to get it to drop down to a quadratic and find the other 2. So let's take the ones that we've been given, 3 and -3, and just do one at a time with some synthetic division. Well, let's start with 3. And let's write down our coefficients of 1, 3, -16, -27, and a 63. Let's drop down. Oh, didn't want to do that. What button did I press? Okay. That's not what I wanted. There I am. Dropping down the 1. Gosh, dropping down the 1. Please don't make that mistake. 3 times 1 is 3. We get a 9. 27. If I subtract those, I get an 11. Multiply those, a 33. Subtract that out. What is that? I didn't want to do that. I didn't want to close that out either. I'm going to have to come back and open it. I knew I made a mistake somewhere. Let me erase that line and erase that line and start over. Drop down your 1. So 3 times 1 is a 3, and 3 plus 3 is 6, not 9. Multiply these two out, we get an 18, and if we subtract those two, we get a 2. Here we get a 6, and if I subtract those, I get a negative 21. And that times 3 is a negative 63, and I get a remainder of 0. Let me tell you why I knew I made a mistake. I knew that 3 was a 0 of that function. And I was noticing that I was not going to get a remainder of 0. Well, I should expect to get a remainder of 0 if I'm dividing by something that is a 0. So I knew I made a mistake somewhere, so I had to go back and find it because the remainder should be 0. And that's something for you to look for. If you're not getting a remainder of 0, you've made a mistake. You might have written in the number in the box wrong, you might have miscopied one of your coefficients, or you may have added or subtracted wrong. So you'll need to go back and check. But what this does is this validates, yes, 3 is a 0. How am I going to prove that negative 3 is a 0? Synthetic division, but here's the trick. When you're doing this, you want to do repeated synthetic divisions off of the result. Otherwise, you'll never get it down to a quadratic. That is so important. Repeated synthetic divisions off of the previous quotient. It's the only way, again, we'll get it down to a quadratic. So the first degree, just to kind of map this out, the first degree was x to the 4th. When I divided, it dropped down to an x cubed. Well, it's not down to a quadratic yet until I divide it one more time to get it down to a quadratic. This will be a negative 3, that'll be a 3, negative 9, this will be a negative 7, positive 21, 0. I was expecting that. When my remainder is 0, it tells me the number in my box is a 0. So negative 3 is a 0. Well, I knew that. They told me that. But my goal was to get it down to that magical quadratic, which is here, that I can finish to solve and find my answer. So this is an x squared plus 3x minus 7. This quadratic is going to allow me to find the last two solutions. X squared plus 3x minus 7. Up here we had a similar one. 2x squared minus 7x plus 3. That one factored. I don't believe this one's going to factor. So if your quadratic doesn't factor, we use the quadratic formula. Negative b plus or minus the square root, b squared minus 4ac all over 2a. And you know the values of a, b, and c are the coefficients. Negative b is going to be a negative 3 plus or minus the square root. B squared will be 3 squared, which is 9, minus 4 times a, which is 1, times c, which is negative 7, all over 2 times a, which is 2 times 1. And so check, negative b plus or minus b squared, 3 squared minus 4, ac. Now let's clean up that radical a bit. Let's bring it up here. So I'll have 9 plus 28. So under the radical, that's going to give me a 37. That 37 doesn't reduce. I can't do any canceling. So this is actually the final answer to that quadratic. Now let's list all the solutions like we did earlier. So there are 4 solutions. Let's list all 4 out. The first one was 3, which they gave us. The next one was -3, which they gave us. Then we have a -3 plus square root of 37 over 2, and a -3 minus the square root of 37 all over 2. Total of 4 solutions. 2 they gave us. By synthetic division, I was able to cull those 2 out, get it down to a quadratic, and find the last 2 from that quadratic that was left. The x squared plus 3x minus 7. Look over that. So those are our 4 solutions.